For the last part of the equation of circle, then we are going to discuss is about the intersection of a straight line and a circle. And for the intersection, I think because for this, I don't want to go through about the PowerPoint. I would like to discuss some more in your lesson worksheet, but I just want to point out the key point in the PowerPoint here. Let's look at this slide. This is the 5th slide, and you can get the summary about what is the situation of a straight line and a circle. I mean, how they are intersect. So for a straight line and a circle, I think we only have 3 cases for the intersection. Sometimes the straight line, maybe if you look at the straight line here, the straight line will not intersect with the circle. And the second case is that the straight line only intersect with the circle with one intersecting point. And the last situation is that the straight line will intersect the circle at 2 points. And actually, this is quite similar to the discussion that we had discussed for the delta. That means the discriminant delta. The delta of a quadratic equation, if it is greater than 0, there are 2 intersecting points. That means similar to the 2 roots, 2 distinct real roots. And then the second situation is that if delta is equal to 0, that is one double real root, or you may say that the number of intersections is only equal to 1. And lastly, if the delta is less than 0, then there are no intersection. And I think this is the most important part that you have to note about in this section. So I told you that in this section, I don't want to go through about the PowerPoint. Then let's look at your lesson worksheet here. So for the lesson worksheet, actually this is your homework. You have to finish it. And then for the lesson worksheet, you can see that also the summary about the situation of the intersection of a straight line and the circle. And for this, first of all, we may have the straight line, the equation of the straight line here. That means we always say it as equation 1. And then the second equation is about the equation of circle, because if there is a straight line and there is a circle, we have 2 equations, one for the straight line and the other one is for the circle. And then you have to substitute the equation 1 into equation 2. And then you will get the quadratic equation in X. And then we only need to consider the delta. Then we know the number of points of intersection here. There are those situations. So let's look at some examples here. So for the example 1, I think you can read it by yourself, and I just want you to get the idea when you have to consider the delta. That means if the question asks you how many, the number, how many point of intersection. Okay, so for this instant practice 1, you are asked to find the number of points of intersection. So you know that because you are asked to find the number of points of intersection, then you know that you have to find the delta. And then you need to consider, you need to consider delta. But before to consider the delta, you have to look at the equation of the straight line, also the equation of circle. Then try to mark it as equation 1 and equation 2. And then you have to substitute equation 1 into equation 2. But you can see that because here, now equation 1, I cannot find any subject. Do you remember how to form the subject? Subject 要做主項啊. That means the only variable on the left-hand side. Then I may move y. Okay? Y may be moved to the right-hand side. I may move this y to the right-hand side. Then it will become positive y. And then on the left hand side, it is 3x and then minus 13. So here I can make y as the subject. After I make y as the subject, then I can move, okay? Then I can move it. Sorry, it is not, yes, it is 3x and then minus 13. And then I can substitute. Now it is called as equation 3 into equation 2. So for this, substitute into equation 2, change all the y to become 3x and then minus 13. Okay, and then minus 13 here. And then I think you can try to do the follow-up calculation here. And after you get the quadratic equation, try to consider delta. Okay, after you get the quadratic equation, then consider delta. And delta, remember, it should be b squared minus 4ac. And then try to check what is the value of delta finally. Okay, if the delta here is greater than 0, for example, if you look at the instant example 1, which is greater than 0, then the number of points of intersection is equal to 2. If it is equal to 0, then the number of intersection is equal to 1. If it is less than 0, then the number of intersection is equal to 0. So I think this part is easy for just to learn about how to find the number of points of intersection. But actually, it's not the most important part in this section. Okay, so for this part, I don't want to discuss any more about this part with you. So for this part, I think you can try it by yourself to do it. But I just want to discuss the last question in this part is question 5. Because for this question, you have to consider if the circle here does not intersect. Okay, now you can see that does not intersect. Does not intersect, that means you know that that is the case about that the circle is here and then the straight line is here. Then they are not intersect by each other. And you know that if in this case, you know that actually delta, okay, in this case, you know that delta equals to 0. Okay, in this case, you know that delta equals to 0. But how to set delta? First of all, we have to get the equation of the straight line and the equation of circle. But here, I just get the equation of circle. Then where is the equation of the straight line? Look at here, because it is compared with the x-axis. X-axis, what is the equation of x-axis? It is y equals to 0. Okay, the equation of x-axis, that is y equals to 0. Okay, so there are two equations. This is the equation of the straight line, or then you may say that this is the equation 1 and this is the equation 2. Then try to substitute equation 1 into equation 2 and then set the delta, which is, sorry, it is not equal to 0. It should be less than 0. Okay, I say wrongly about that because they didn't have any intersecting point. So the delta should be less than 0. Okay, so for this part, you have to set the delta is less than 0. Then I think you can find the smallest value of k. Then check if it is correct. Okay, so I think you can try this and then you can do it correctly. Okay, and then for the next part here is that this part is more important than the previous part. For this part, we are going to look at the coordinates of the points of intersection. Because for the coordinates of the points of intersection here is more important than the previous part. Then how to find the intersecting point? Actually, just like to solve the simultaneous equation, okay? Just like to solve the simultaneous equation of the equation L and the equation of C. That means the equation of the straight line and the equation of circle. So for this part, you have equation 1 and equation 2. It is given from the question. Then try to solve it. Okay, and I think this part you had learned before. So you can find the coordinates of the intersecting point. Sometimes there may be one intersecting point, or maybe two intersecting point, or sometimes there may be no intersecting point. Okay, so for this part, I think it's not quite difficult about that. And then I may just try to look at this one example here. I may take the instant practice as one of the example. Then you can see that for equation 1, equation 2, there are two equations, and then you are asked to find the coordinates of the point of the intersection. That's why you have to solve the equation. And if you look at these two equations, you saw that equation 2, x is the subject already. Then no need to change the subject. Then just try to substitute equation 2 into equation 1. And then when you solve x, just put it as 2y and then plus 13. Okay, and here 13. Okay, then try to expand the bracket, and then I think you can solve for the value of y. And then after you get the value of y, try to get the value of x as well. And then you can get the coordinates of the point of intersection. And in this case, you can see that there are some hint for you that only one bracket, that means only one point of intersection. That means for here, the y, I mean the value of y, you will get only one value. Then only have one point of intersection. So just try to solve the two equations, then you can find the point of intersection. And then next is that for this part, I hope that you can try. Okay, and I just want to discuss here, I mean the last part. Okay, the last part here, the last question here, also question 5. Now I want to draw the figure for you to have reference about that, to help you to finish this question. There are circle, okay, maybe I draw a circle here, and then and a straight line L intersect at 2 points. I don't know where is the straight line, but there are some more given information that the diameter of C, this circle, I call it as C. Okay, this circle, I call it as C. And then there is a straight line. And then for the straight line, it passes through the diameter of C. The diameter, for example, I may use different color for this line. Okay, sorry. Okay, for the straight line, I may use the blue one. The straight line L may be something like this. Maybe I move a little bit here. Okay, because the straight line L, it passes through the diameter of C, and then I know that the diameter of C is here. I may change here, and then I change the color, and then here is the diameter, right? And the center of C should lie on the diameter. Here is the center. I may mark the center as O. Okay, the center of C should pass through the line L, and then for this, I may mark this line segment as L, and then I know the diameter of C with slope -2. That means the slope of this line segment is equal to 2, okay? This line segment, the slope, is equal to 2. And then I also can find the center of the circle O from the equation of circle. After I get the coordinates of the center and I know the slope of equation of L, then I can use the point slope form to form the equation of L. So I just want to give you such remark about the situation for this question. Then I think after you get such information, you can finish this question easily. And then for the last part of this section is that this is the most difficult part here, because for this part you need to consider the equation of tangent. What is the meaning of equation of tangent to a circle? Tangent, remember, tangent, that means only cut the circle at one point. I mean the straight line cuts the circle at one point. Then the straight line L here called as the equation of tangent of the circle. And then we have to review some of the properties of circle here, because if this is the tangent, and do you remember tangent always perpendicular to the radius, that's why here PG always perpendicular to the straight line L. They're perpendicular to each other. And also if straight line L is the tangent to the circle, that means only have one intersecting point with the circle. That means if I know that it is the tangent, I know that after the substitution of the equation of the straight line to the circle, the delta should equal to 0, because there are only one intersecting point. Okay, so you should get such idea about this. And then let's look at some example here. For example, for this instant example 1, you can see that in the figure, G is the point and G is the center of the circle. And then find the equation of tangent L. This is the equation of tangent L to the circle at P. Then how to find the equation of the straight line? Then we always need to find the point. I know the point, but now I don't know the slope of L. Then how to find it? We have to use the first property here. The first property is that L and the center, okay, the radius are perpendicular to each other. That means here GP is perpendicular to L. And for G and P, I got the coordinates of point G and point P. Then I can get the slope of PG. So first of all, I may calculate the slope of PG. And next, I know that because they are perpendicular to each other, then their slope times together is equal to -1. Then I may just let M be the slope of L. And then slope of L times slope of PG. That is 1/3. I found it before. That is equal to -1 because they are perpendicular to each other. And then I find the slope of L, which is equal to -3. After I got the slope of L and I got the point P here, because the intersecting point of the line L and the circle is at the point P, 4, 3. Then I got the slope and point, then I can form the equation of the straight line, I mean the equation of tangent L, which is by using the point slope form, then I can form the equation of L here. And then for this instant practice 1, just do the same that, because if you know L is the tangent, and then you got the point of intersection Q, then you can find the slope of GQ first, and then you can find the slope of L, then you can apply the point slope form to find the equation of L as well. So for this one, just follow this instant example 1. That's why I don't want to repeat about that. And then the next few questions, I think almost the same. I mean, question 1 and question 2. It is similar to the example 1. And then let's look at the second example is that another type of the question related to the tangent is that, can you see that here the straight line, this touches, that means only intersect the circle at one point. That's why for this, we should think about that delta equals to 0. Because of touches, that means intersect at one point only. That's why, first of all, I may substitute this equation into the equation of circle, the straight line, okay? The equation of the straight line, substitute into the equation of the circle. And after this, I got the quadratic equation in X. And for the C, actually it is a constant only. I don't care about this constant first at this moment because I just want to form the quadratic equation in X. That's this equation. And I know that the straight line touches the circle. That's why delta equals to 0. Okay? And then you can solve for the value of C by setting delta equals to 0. So that's why even though there are some unknown in the straight line or sometimes some unknown may be in the equation of the circle, you can try to set the delta to solve for the unknown. So for this case, you are using the second property here for the equation of tangent to a circle. Using the second property, after the substitution of the straight line into the equation of the circle, set the discriminant, that means the delta, equals to 0. Then you can solve for this question. And then the instant practice and question 3, question 4, I think is the same about this. You also can see the word touches. So also try to set up the quadratic equation in X and then set delta equal to 0. Okay. And then for this question, I mean question 5 here, I just want to discuss or give you some hint about how to do this question. Because someone claims that the two straight lines which touch the circle this with the same y-intercept one are perpendicular to each other. So let's check, and then what is the straight line? And now I just know the y-intercept of the straight line is equal to 1. And then, so first of all, you may let the straight line be y equals to, I don't know the slope, but doesn't matter. I may just let it as m as the slope, mx plus the y-intercept. And now I know that the y-intercept is equal to 1. And this is the slope-intercept form of the straight line. Because now I don't know the straight line, then I may let the straight line be y equals to mx plus 1 be the equation, okay, be the equation of one of the straight line. And then try to substitute this into this. Okay. Into this equation. I mean, try to substitute the equation of the straight line to the equation of the circle, and then after some calculation, you will get the quadratic equation in X. Okay. And then after some calculation, I don't want to calculate. You can form the quadratic equation in X by the substitution. And next, try to set delta equal to 0. Then you can find the value of m. Okay. After you get the value of m, that means the slope of the straight line. Then try to compare. I mean, try to check. because you can find the two values of m here, I mean the slope of the two straight line, then check their slope, are they perpendicular? That means to check, are the two values of m times together is equal to -1. If they are equal to -1, that means they are perpendicular. Okay, if not, they are not perpendicular. So I may just write down some more note for you that after the substitution, set delta equals to 0. Then after some calculation, you will get two values of m, two values, one and then or another value. Okay, you will get two values. Then I may call these two values as m1, m2. Okay, maybe I call it as m1, m2. These two values, because I don't want to do the further calculation. You should try to do it by yourself, but I just want to discuss in more detail with you. And then let's check, are these two values, when they are times together, which is equal to okay, when you times this value, I mean these two values together, are they equal to -1? Okay, I don't know they equal to -1 or not. I don't know. Just check. If times together equals to -1, that means they are perpendicular to each other. But after times together, if it is not equal to -1, that means they are not perpendicular to each other. Okay, so this is there is some hint for you to do this question 5, the level up question. So in this worksheet, I think the rest is not difficult. Only the level up question is a bit difficult, but for all the level up question I had discussed with you, I hope that you can try your best to finish this worksheet and hand in your homework on time in Google Classroom. Okay.